For the first time in over 4 centuries, humanity may be on the brink of witnessing a celestial event so powerful, so brilliant it will be visible to the naked eye. No telescope, no filters, just a cosmic giant lighting up the sky. The star in question is Betelgeuse. Despite the spooky folklore surrounding its name, repeating it 3 times won't summon anything paranormal. But what it might summon is one of the most spectacular light shows our species has ever seen. This red supergiant, located about 600 light-years from Earth, has recently been behaving unusually, flickering, dimming, and brightening, much like a giant, dying heartbeat in the night sky. Those erratic changes have left scientists wondering if Betelgeuse is nearing the end of its life in a grand and fiery supernova. Today, we delve deep into the mystery of this remarkable star, one of the most recognizable in our sky, sitting on Orion's shoulder, possibly not for much longer. Because Betelgeuse is 600 light-years away, the light we see from it today actually began its journey towards us 600 years ago. So if it exploded in the past 6 centuries, the light from that explosion could reach us at any moment, even tomorrow. When it does go supernova, it will be the brightest one humans have ever seen. Just how bright, you ask? So bright, it could be visible during the day. But will it be dangerous? Could it harm Earth? And why are its recent patterns of behavior so puzzling to astronomers? To understand the situation, let's take a step back. Our Sun has been burning steadily for about 4.6 billion years. By contrast, Betelgeuse is relatively young, only about 10 million years old. That means it's so freshly formed, there's not even been time for rocky planets like Earth to evolve in its orbit, and likely never will be. Unlike our Sun, which has a slow and steady lifespan ahead, Betelgeuse is burning through its life rapidly. Born with more than 15 times the mass of our Sun, it has always lived large and fast. Even before expanding into a red supergiant, it was already emitting tens of thousands of times more energy than the Sun. Today, that number has shot up to over 100,000 times. It's not just a bright star, it's a fiery, unstable furnace showing signs of imminent collapse. When a red supergiant like Betelgeuse runs out of fuel, its core begins fusing increasingly heavy elements. First carbon, then oxygen, silicon, and finally iron. But fusing iron doesn't release energy, it absorbs it. This spells the end for the star's nuclear furnace. Without the outward push from fusion, gravity takes over. The core collapses. What happens next depends on Betelgeuse's true mass. If it falls on the lower side, around 10 to 15 times the Sun's mass, then it will likely explode in a massive supernova, leaving behind a neutron star. But if it's heavier, closer to 20 times the Sun's mass, the collapse could be too strong for even neutrons to resist. In that case, Betelgeuse could collapse directly into a black hole, possibly without even producing a visible explosion. One moment it would be there, then suddenly gone. Right now, we don't know Betelgeuse's exact mass or even its precise distance from Earth. These uncertainties make its fate unpredictable. Even small changes in its composition or rotation could determine whether it dies with a bang or simply vanishes. If the balance is just right, though, and the core collapses in a way that causes an outward rebound, the resulting supernova could be one of the most brilliant displays the night sky has ever witnessed. To put this in perspective, the Sun's luminosity is around 3.8 ex 10^26 watts. A supernova observed in 2015, known as ASASN 15LH, reached a peak luminosity of around 2x 10^38 watts. That's the combined energy output of more than 500 billion suns. We didn't see that one with the naked eye because it happened in another galaxy. But Betelgeuse is practically next door, cosmically speaking. Its explosion would light up our sky, likely even outshining Sirius, the current brightest star visible from Earth. It would remain visible for weeks, maybe even during daylight, hours. So, should we be worried? The short answer is no. A supernova would need to occur within about 100 light years to pose a threat through harmful radiation or other impacts. Betelgeuse is comfortably beyond that range, so Earth would remain safe. For comparison, if a star like Alpha Centauri, only about 4 light years away, were to explode, it would shine as brightly as the moon and could pose real risks. Fortunately, Alpha Centauri isn't large enough to become a supernova. There are other red supergiants in the galaxy that might explode eventually, but Betelgeuse is the one drawing the most attention right now. One key reason? Its rotation. Using the ALMA telescope array, scientists have determined that Betelgeuse is spinning unusually fast, completing a rotation roughly every 20 years. That translates to a surface speed of about 18,000 kilometers per hour, much faster than expected. For a star of its size, this challenges current models of stellar evolution. To understand a star's rotation, astronomers apply the Doppler effect, similar to how a siren seems to rise in pitch as it approaches, then falls as it moves away. By observing subtle shifts in the wavelengths of light from different parts of Betelgeuse's surface, researchers measured its rotational speed. One possible explanation for the star's surprising spin: stellar cannibalism. Betelgeuse may have absorbed a smaller companion star, gaining momentum in the process. Evidence for this comes from the unusually high nitrogen levels in its outer atmosphere, indicating that its interior was recently mixed. This supports the idea that something dramatic spun the star up. Detailed simulations suggest that as Betelgeuse aged, its outer atmosphere may have expanded into the orbit of a nearby star. That material was pulled onto the companion, increasing its mass. Eventually, the companion plowed through so much gas that friction slowed it down and dragged it inward. Whether Betelgeuse fully absorbed this star or not remains uncertain, but recent modeling supports the idea that the two stars interacted. In fact, Betelgeuse is a variable star, meaning its brightness fluctuates over time. It has two main cycles, one lasting just over a year, and another around 6 years. A recent study using computer simulations explored the cause of these cycles and found that the most plausible explanation may be a hidden companion star, informally nicknamed Betelgeuse. However, unless Betelgeuse explodes, we may not get direct evidence of this secondary star anytime soon. As for when Betelgeuse might go supernova, that remains a mystery. Estimates vary widely, with predictions ranging from 10,000 to 100,000 years in the future. But because we're seeing the star as it was 600 years ago, the explosion could have already happened. We're simply waiting for the light to arrive. Now, let's talk about something equally dramatic: close encounters between stars. Our solar system seems like a quiet neighborhood, but we live in a galaxy with 200 to 400 billion stars. The Milky Way stretches around 100,000 light-years across, and while stars are widely spaced, they're all orbiting the galactic center. Red dwarfs, which make up about 75% of stars in our galaxy, are small and numerous. Stars travel at about 20 kilometers per second relative to one another, which means stellar flybys, though rare, do happen. On average, the closest stars come to our Sun is around 500 astronomical units, about 10 times the distance from the Sun to Pluto. These events happen about once every few 100,000 years. Even rarer are encounters within 100 AU, about once every billion years. While such flybys don't typically disrupt planetary orbits, they can affect the Oort cloud, a distant shell of icy objects at the edge of the solar system. Over millions of years, these disruptions can send comets into the inner solar system, increasing the risk of impacts. One star, called Schultz's star, passed relatively close to our solar system about 70,000 years ago. But new research suggests an even closer encounter may have happened. Two recent studies propose that a rogue star may have come within 110 astronomical units of the Sun, closer than even the Voyager 1 probe, which is now about 164 AU away. That's astonishingly near in cosmic terms. Simulations show that such a close encounter could explain the strange orbits of certain distant objects, like the dwarf planet Sedna or other trans-Neptunian bodies with retrograde orbits. It might also explain the irregular moons of Saturn, Jupiter, and Neptune, some of which may have been captured from the outer solar system during this gravitational disturbance. These findings suggest that billions of years ago, a star slightly smaller than the Sun, with about 0.8 solar masses, passed within 4 times the distance between the Sun and Neptune. That one near miss may have helped shape the chaotic outer regions of our solar system, a forgotten chapter in our planet's deep past. And so, whether we're watching Betelgeuse for a possible supernova or looking back at ancient stellar flybys that left their mark on our solar system, the night sky remains full of stories waiting to unfold.